Dear colleagues, thank you very much for attending to the ICAR Proficiency Test webinar, and I hope that you will find it interesting. I'm Silvia Orlandini, ICAR staff, and responsible for the plan and development of the ICAR Proficiency Test for the milk analysis. In this presentation, I will present to you the ICAR Proficiency Testing Scheme milk parameter trend over the time, their precision and their comparability. ICAR Proficiency Test is accredited ISO 70043 and it started its activity in March 2016. The plan is to organize 2 rounds per year in March and in September. Nowadays, in our database, there are 97 participants from 39 countries that represent 4 continents. These are the parameters offered by the ICAR Proficiency Testing Scheme and the number of participants over the time. You can see from these graphics that for the somatic cell counting and infrared methods, the number of participants are increasing over the time. The output of the ICAR proficiency test are 2 types of reports, reference method and routine methods. Both are provided with an individual performance. The reference methods report indicates that the parameters indicated are analyzed with chemical methods, also so-called reference methods. Example, fat parameter analyzed by Rosgotel, protein analyzed by Kildall. There are some exceptions. When there are not enough participants for one method, example the microscope method for the somatic cell counting, we collect the results for both method, microscope method and fluoro-optoelectronic. So we will have only one statistical elaboration that collate all the results from both methods. The routine methods means that the parameters are analyzed with so-called alternative methods, or in this case infrared for fat, protein, lactose, urea. Now, one by one, we are going to illustrate to you the precision of the different parameters offering the ICAR proficiency testing scheme and the comparability of the method used. For fat parameters, in the first graphic is reported the precision of Rose-Gottlieb method, and we can see that repeatability and reproducibility is always below the ISO limit, with exception of the reproducibility of the last PT round. For infrared, while the repeatability is always below the ISO limit, the reproducibility, especially in the last proficiency testing scheme, is upper the ISO limit. It means that the standard deviation between the laboratories and the variability between the laboratories increased compared to the first PT trials. In these graphics are reported the comparison between the assigned values determined with the Rose-Gottlieb and the assigned values determined with the infrared method. The bias between the two mean assigned values in each round are reported here in this graphic below in yellow. And you can see that there is constantly, with a few exceptions, constantly an underestimation of the infrared method. But this underestimation is really small. For protein parameters, the precision shows that the repeatability is always lower than the limit indicated by ISO for chemical Kildall methods and alternative infrared methods, while the reproducibility for Kildall is at the limit or slightly higher, and for infrared is always lower, with 4 exceptions that show higher values. In these graphics are reported the difference between the assigned values of proficiency tests of Kildall methods and the assigned values of infrared method. We can see in the second graphic that there is a constant underestimation of the infrared method. Likely this underestimation is going to decrease in the last PT round. Lactose parameters show a repeatability that is always lower than the ISO limits for HPLC and for infrared methods. At the contrary, the reproducibility is always above the limits. A trend of reproducibility improvement is showed in the last PT rounds. The comparison between HPLC method and infrared method for lactose parameter show that there is a slightly underestimation of infrared method. This underestimation is around 0.02 grams per 100 grams. So it's quite small, and it's important to continue to monitor the comparison between these two methods. For urea parameter, in both graphics we have reported the precision limit of differential pH reference method. The performance of differential pH is perfectly aligned with the ISO limit for repeatability and reproducibility. The precision of infrared is less precise than differential pH. Because we haven't in the ISO standard the limits precision for infrared method for urea parameter, the ICAR milk analysis subcommittee will consider to revise this limit to be adequate to infrared method. The comparison between differential pH and infrared for urea parameters showed a slight overestimation of infrared in the order of 2 mg deciliter, with the exception of 2 PT rounds where this trend is inverted. For beta-hydroxybutyrate, because we haven't the limit precision in the ISO IDF standard, milk analysis subcommittee approved to use the mean values of the precision obtained in the last PT rounds. Using such limit, we can see that the repeatability is always below the limit with one exception, while the reproducibility shows a very interesting trend of improvement in the last 3 PT rounds, hoping that this trend will be confirmed in the next rounds. In this slide, you can see the precision for somatic cell counting. This precision has been calculated considering the results of microscope method and fluoro-optoelectronic method. In the ICAR proficiency test scheme, usually no more than 3 laboratories provide results obtained with the microscope method. So this picture well represents the precision of the fluoro-optoelectronic method. You can see that the repeatability is always below the limits. The reproducibility was constantly higher than 10%, and surprisingly, in March 2021, for the first time, the reproducibility had a values of 7%. A reason of these very good results could be that 1 year ago, the European Community Joint Research Centre certified reference material for somatic cell counting started to be commercialized. In the last 2 PT rounds, thanks to the availability of the certified reference material, we have calculated the assigned values of the ICAR PT samples according to the metrological rules described in the IDF ICAR Bulletin 508 published in spring 2021. In this graphic is reported the relative difference of ICAR PT assigned values and assigned values traceable with the certified reference material. If we consider the entire range, the ICAR PT population overestimate 3.5%. If we exclude the lower level of concentration below 100,000, the ICAR PT population overestimate 2.5. This is the first qualitative parameter is a pregnancy-associated glycoprotein based on the ELISA method. To be underlined that all the participants used the same manufacturer kit, and the performance is excellent in all round provided, with a very small exception in March and September 2018, where there was one laboratory that provided one result not correct. Another qualitative method is the DNA with the PCR method. You can see from the graphic on the left side that we haven't a lot of participants nowadays. What we are providing to each laboratory is an individual performance where each pathogen is identified by a color, and the same color is reported on the results of the participants. In case the kit used has the probe of the pathogen spiked in the milk and this is not identified, we will report a red flag. In case the kit used hasn't the probe for the pathogen spiked in the milk, obviously it will be not identified and the performance will be acceptable as well. To conclude this presentation, ICAR confirmed that will continue to monitor the method performance for different parameters. ICAR proficiency test scheme is a useful tool to describe the method performance. ICAR milk analysis subcommittee as well will evaluate the data and if necessary will plan action to improve the analytical performance, for example questionnaire that can collect information on the method application with the final aim to improve precision and equivalence. A general consideration is that the repeatability performance is always below the indicated limit for reference and routine methods. At the contrary, the reproducibility of alternative methods is frequently above the limits. It means that the method is correctly applied and the instruments are well maintained, but the calibration settings are not equivalent. The constant participation in the ICAR-PT should gradually motivate to move closer to the assigned values, but for sure the possibility to have a certified reference material, as it is nowadays for the somatic cell counting, is a stronger motivation. Thank you very much for attending to the ICAR webinar, and I'm looking forward to see you in the next presentation scheduled today. Thank you again.